let's solve some absolute value equations. So first things first, we've got 5 times the absolute value of 3 minus 4x is equal to 115. Well, my first goal is to look at the absolute value bars and do algebra before I do my algebra. So I need to get the bars isolated first. So I used a yellow highlighter and I said, hey, let's pretend that this problem is 5 yellow. So if I have 5 times yellow, how do I get yellow isolated? Well, I need to divide both sides of the equation by 5, and that will get the bars isolated. So if I do 5 divided by 5, that cancels out, and I do 115 divided by 5, that should be equal to 23. Now, if I look at the bars are equal to a positive number, so what does that tell me? It means that the problem is solvable, and I write it in 2 separate equations. Either 3 minus 4x is equal to negative 23, or 3 minus 4x is equal to 23. Now, before I go on, I did see a few errors on handling the 2-step equation when the x is on the right side of the right side. It's at the right part of the left side of the equation. So the point is, if this makes you feel a little bit anxious, where you like the x on the left side, I wanted to show you that you can rewrite this problem by looking at the signs of 3 and the 4x. That the number in front of 3 is non-existent, so we can call it positive 3, and we have negative 4x. So as long as you keep the signs, you can switch the problem by making this negative 4x plus 3, and now you can subtract 3 from both sides. Okay? So now that we have subtracted 3 from both sides, negative 4x is equal to positive 20. And then we divide both sides of the equation by negative 4, giving us one of the solutions as x equals negative 5. Looking at the other side of the equation, remember that it's the same old song and dance, that if I would like to ease my anxiety by having 3 minus 4x easier for me to undo the layers, I can rewrite the problem as negative 4x plus 3 is equal to negative 23. And then I'm going to undo the layers like a normal 2-step equation. So I subtract 3 from both sides. Remember, this is negative 23 minus 3. So I'm left with negative 4x is equal to negative 26. Now, we need to undo the layer on x, so we're going to divide both sides of the equation by negative 4. You have the choice of either writing it as a decimal or as a simplified fraction. So if this was a simplified fraction, you'd notice that this was negative divided by negative. So that'd be positive 26 over positive 4, or 13 over 2. I personally like it as a decimal because it's much easier to write. It ends in a nice 0.5. So the solution set is x is allowed to be positive 6.5 or negative 5. Okay. Moving on to problem number 2. Let me just cover that up really quick. So let's see if we can do this together. Let's see if you can do this problem independently. 1 minus 5x in the absolute value bars plus 9 is equal to 38. So once again, are the bars isolated? No. So what I'm going to do is I'm going to put a target on there and say, you know what? If it makes life easier to get a highlighter and call it yellow, be my guest. So I've got yellow plus 9 is equal to 38. And then I'm going to solve for yellow. If this problem was yellow plus 9 is equal to 9, I would need to subtract 9 from both sides. So I'm going to do that. Oops. Let me just get my highlighter. I dropped it on the floor. Sorry about that. So if I subtract 9 from both sides of the equation, that isolates the absolute value bars, or if you prefer, yellow. I got yellow isolated. So now I've got the absolute value of 1 minus 5x is equal to 29. So are the absolute value bars isolated? Yes. Is this problem solvable? Yes. So now I'm going to split this into two equations. Either 1 minus 5x can be equal to negative 29, or 1 minus 5x can equal positive 29. I accidentally put a negative in there, so I just corrected with a positive sign. But yeah, you don't have to write positive because if it doesn't have a sign, it's automatically positive. So now my anxiety is a little bit spiking because I've got 1 minus 5x. Now, if you know how to undo the layers where it's 1 minus 5x, be my guest. I'm not going to stop you, but I noticed a lot of error, so I'm going to show it the other way. Remember that this is a positive 1 and this is a negative 5x. So I can switch the terms on the left side of the equation by making this negative 5x plus 1 is equal to 29. Now then, how would I undo the layers of x in this case? I would need to subtract 1 from both sides. Now that I've got negative 5x isolated, this becomes negative 5x is equal to 28. And then I divide both sides of the equation by negative 5. Now, you could write this problem as 28 over negative 5, and it can't be simplified. Be my guest, that's totally fine. Or if you like it as a decimal, 28 divided by 5 is 5.6, and a positive divided by negative is a negative. So one of the solutions is negative 5.6. But we're not done. So we're going to look at the left side of the equation. 1 minus 5x is equal to negative 29. If it makes life easier for you to keep the signs the same and switch it so that we have negative 5x plus 1, be my guest. If you know to subtract 1 from the beginning, that's fine as well. I just want you guys to be flexible. So then I'm going to subtract 1 from both sides. So that'd be plus 1 minus 1 cancels out. Negative 29 minus 1 is going to create negative 30. So now I've got negative 5x is equal to negative 30. So my final undo step would be to divide both sides of the equation by negative 5. Now, negative 30 divided by negative 5 is positive 6. So x is equal to positive 6. These are the two solutions in the solution set. You can plug them into the original equation and you'll get true statements, as in both of them will get you the output of positive 38. Okay, now then, let's go to problem number 3. I don't want to spoil the answer, so let me cover this up really quick. There we go. So let's take a look at problem number 3. We've got 8 times the absolute value of 6x minus 4 plus 50 is equal to 2. So I apologize, that was originally a 7 and I noticed an error, so I had to make that into an 8. So if I were to solve 8 times yellow plus 50 equals 2, I have to do algebra before I do algebra. 8 yellow plus 50 is equal to 2, so I need to subtract 50 from both sides to get yellow isolated. Now that I've subtracted 50 from both sides, I get 8 times the absolute value of 6x minus 4 is equal to negative 48. Or I can look at this like 8 yellow is equal to negative 48. Now, I'm going to divide both sides of the equation by 8 in hopes that yellow gets isolated. And the bars do get isolated. So now I've got the absolute value of 6x minus 4 is equal to negative 6. And so that begs the question, is this problem solvable? No, the bars equal a negative output. This means that x has no solution. Strictly for this reason. Normally I'd put it right below, but I put the next question right there. But yeah, so that's how you can tell, even if we did all the algebra correctly, this problem is unsolvable because the bars equal a negative output. There's no such thing as negative distance. Okay, let's take a look at problem number 4. See if you could do this problem independently. First things first, can I make the judgment that this has no solution because the output is negative? No. Get the bars isolated first before you make a judgment. Okay? So first things first, I'm going to target the absolute value bars because my goal is to get them isolated. So now I've got the problem, -9 yellow minus 2 is equal to -83. Well, let's get yellow isolated. How would I isolate yellow if the problem was -9 yellow minus 2 is equal to -83? Okay. I would need to add 2 on both sides in hopes to get yellow isolated. In the next line, I've got -9 times yellow is equal to -81. Can I make the judgment that this problem is unsolvable right now? No. So I need to divide both sides of the equation by -9, and that's going to get yellow isolated, or the bars. After all, -9 cancels out with -9. -81 divided by -9 is +9. So now what do I need to do? This problem is in fact solvable. Because the bars equal a positive number, I'm going to split this into 2 separate equations. So now I've got 8 minus x is equal to -9, or 8 minus x is equal to +9. So there's 2 things. One, there is no coefficient, there's no coefficient in front of the x, so what can I automatically do? I can put a 1. And secondly, that makes me nervous. 8 minus 1x is equal to 9. So if you know how to solve for x from here, go for it. But I notice a lot of errors, so I'm going to rewrite the problem by putting -1x in front and +8 on the other side. Oh, +8 is equal to 9. And now I'm going to undo the layers of x by subtracting 8 from both sides. So now I've got -1x is equal to 1. But I'm not solving for -1x, I'm solving for x. So since I've got -1x is equal to 1, I'm going to divide both sides of the equation by -1. And thus, x is equal to -1. That's one of our solutions. The other way is, hey, same old, same old. There's no coefficient in front of x, so I can put a 1, if that makes my life easier. And then I'm going to rewrite the problem as -1x plus 8 is equal to -9, because that makes me feel safe. And then I'm going to subtract 8 from both sides. -1x is equal to -9 minus 8. That's -17. And if I divide both sides of the equation by -1, that leaves me with, canceling out the coefficient, -1 over -1. A negative divided by a negative is a positive. So then x is equal to +17 or -1. Those are my 2 solutions in this problem. Okay, moving on to problem number 5. Let me just put a little cover so I don't give away the answer. All right, number 5. -10 times the absolute value of 2 minus x plus 19 is equal to -51. See if you can do this problem independently. Okay, so the first thing is I want to get the bars isolated, so I'm going to subtract 19 from both sides. Remember, I want to target the absolute value bars before I move on to the next step. Thank you. So I subtract 19 from both sides, and that gets me -10 times yellow, or the absolute value bars, is equal to -70. How would I get the bars isolated now? I'm going to divide both sides of the equation by negative 10. And hopefully that gets the bars isolated. Now that the bars are isolated, is this problem solvable? Yes. So specifically, because the problem started out with, the absolute value, multiply, get negative 10, and add a 19, we get negative 51, we can't make that judgment immediately. Because now that the bars are isolated, I'm going to split this into two separate equations. Specifically, 2 minus x is equal to negative 7, or 2 minus x is equal to 7. So let's start with the right side since I'm a positive person. So if I were to rewrite this problem, I would write this, remember there's no coefficient in front of x, so I can write this as negative 1x plus 2 is equal to 7. Then I'm going to subtract 2 from both sides, getting me negative 1x plus 2 is equal to 7, so I'm going to subtract 2 from both sides. The positive 2 and the negative 2 cancel out, and they get me negative 1x is equal to 5. But I'm not solving for negative 1x. I want positive 1x. So because it's attached to the x, I need to divide both sides of the equation by negative 1. And positive 5 divided by negative 1 gets me x is equal to negative 5. But that's not the only solution. Same thing over here. I've got 2 minus x is equal to negative 7. And there's no coefficient in front of the x, so I can automatically put a negative 1. But I'm going to do it the other way. So if you wanted to write this problem as negative 1x plus 2, go for it. I'm just showing it both ways, that you can, in fact, subtract 2 from both sides at the start. So now that I've subtracted 2 from both sides, I've got negative 1x is equal to negative 9. And now that negative 1x is equal to negative 9, I'm going to divide both sides by negative 1 and get x is equal to positive 9. So in the grand scheme of things, x is equal to positive 9 or negative 5 is my solution set. Okay. Now, problem number 6. Let me turn the page. Nope. Where's problem number 6? Over here. I don't want to give away the answer, so I'm going to go scroll by scroll. So now, see if you can do this problem independently. The absolute value of, 4 times the absolute value of 8 minus 3x is minus 17 is equal to negative 18. So the bars are not isolated, but can I make the judgment that this problem has no solution? Not yet. Even though it's a negative output, I want to get the bars isolated first. So 4 yellow minus 17 is equal to negative 18. So what I want to do is add 17 to both sides in hopes to get the bars isolated. So now that I've added 17 on both sides, I get 4 times yellow is equal to negative 1, or 4 times the absolute value, is equal to negative 1. And then I'm going to divide both sides of the equation by 4 in hopes to get the bars isolated. And now I've got the bars is equal to negative 1/4 or negative 0.25. Is this problem solvable? No. Even though in the beginning it said that the output is negative, part of you wanted to say, oh, no solution right off the bat. No, still put in the effort and then make that judgment call. X has no solution because the bars equal a negative output. So this problem is impossible. All right, one more day of this, and then you guys will have a test on solving absolute value equations where you have to get the bars isolated first. And that test will be due Friday at 11:59 p.m. Have a great day.